Thank you very much. Hello, everyone. I'll try and project so you can all hear me well, but do tell me if I start to fade. This was, I don't know whether you've charted this today, but actually, when I began putting this talk together, which was a couple of days ago, it was about $2,000 less than that. This was this morning, and now it's about $1,500 more than that. So clearly, there's quite a lot of belief out there. I'm going to throw a sceptical light. I'm going to talk about what I mean by being sceptical. Actually, I gave a talk on artificial intelligence for skeptics last week, and I'm trying to turn skepticism into a thing. I'm going to really try to communicate to you, first of all, the core of what I believe blockchain is, and second, why it puzzles me that people have so much confidence in it. Very brief word about me to begin with. I thought some of you who are in startups nowadays might be interested in this picture. This was a startup quite a long time ago. That picture was taken in the West End. I'm leaning against a rack of commodity processors. And essentially, not many people were doing this at the time, and it certainly wasn't called this, but essentially we were doing cloud computing. Any guesses as to when that was?
Years ago?
And don't say 1950s. No?
83.
Sorry?
83.
83. No, that's a little bit far back. 88, that was. That was my first startup company. I became an academic at Queen Mary in London. This is a distributed computer systems book that I put together with colleagues. Moved to California, worked for HP Labs for 4 years working on what typically was called ubiquitous computing then, and was AKA pervasive computing. Moved back to Bristol, was at Bristol HP Labs for a while. HP Labs was behind the formation of the Pervasive Media Studio. Does everyone know the Pervasive Media Studio? It's inside Watershed, and it's a collection of academics, creative technology companies, and artists. And I've been there for a while now, and I work on what I call social video platforms. I'm really interested in software that supports people acting collectively, which is one of the reasons I'm interested in Bitcoin. So climate change skeptics kind of give skepticism a bad name because it's, I consider, merely the denial and refusal to engage with something behind which there's an awful lot of scientific data and thought gone into it. I sort of try and contrast for skeptics with for dummies. You're learning about something enough to be able to criticize it. Okay? I mean, I can criticize air pollution from cars without really understanding how my car entirely works anymore. So I'm interested in this approach to try and learn enough about something to be able to look at it with a certain puzzlement, which after all is the scientific and philosophical method and has been for several centuries. I try not to be cynical, that's different from skeptical. I could be cynical about Bitcoin, which is really a question about my outlook on people's motives. But really what I want to do is to talk about what evidence there is about this system and whether we believe it has certain properties that are claimed for it. So there are many different aspects. One of the things that fascinates me about it, I mean, there's no way, by the way, I should say, it's not like I've got a PhD in this. I'm just like one of you, probably. I've looked into it. It has technical aspects. It has, as I will show, very significant environmental aspects. There are political aspects, both in terms of its own internal organisation and those who participate in it, and obviously there are economical aspects. So there are all these things. There's no way I'm going to be able to cover this. I'm really going to concentrate mostly on the tech and the environmental aspects. The other things will come in of necessity. And I mean, everybody seems to have an opinion about this thing, right? I mean, first of all, I should say I'm talking about blockchain, which is an underlying technology behind Bitcoin. It's also an underlying technology behind many other things. Ethereum, for example. This is Lloyd Blankfein, the CEO of Goldman Sachs. They kind of want to have their cake and eat it, the bankers. Here's a little thing about how consensus, I suspect this man doesn't know what is meant by consensus, not in the technical sense anyway. consensus being something behind a currency. But then on the other hand, he thinks, like all the bankers are coming out today to say this, right? Bitcoin is a bubble, it's going to burst. So he thinks there might be something in it, but not this thing. And of course, why should we believe anything they say anyway? So let's go back to first principles. I'm going to start being a little bit technical, not very. Digital currency, as I will show, has been around for a very long time. Cryptocurrency is a recent term for it. It has a specific meaning. But the core idea is to replace all physical tokens of currency with bits and software, right? I lived in China for 2 months earlier this year, and pretty much all Chinese people pay with QR codes. You read a QR code at the point of the merchant, or you present a QR code which the merchant reads, or you read a QR code off a website. So it's digital. It's digital cash, right? It's all bits and software. There's no physical tokens or anything there. But that's not quite what is wanted here. There's another motivation here, which is to remove the financial institutions that are behind that. Okay. Now, you can argue about what precisely the motivation for that is. You can argue that it's a largely American libertarian political motivation, for example. And you can argue about why you don't like financial institutions. But let's take as granted that we want to eliminate trusted third parties from this system. We obviously want to try and keep low transaction fees. We'll see whether we can do that. And then another goal, this is going back essentially to Nakamoto's original paper on Bitcoin, is anonymity. If I pay with pounds, I'm not giving any identity away, pounds sterling, coins rather. I'm not giving any identity away. That's another culture we might want to preserve. I'm going to assume that you guys are reasonably technical, and these concepts are more or less familiar, but I'll just run over them. A hash, in particular cryptographic hash, is a way of taking some data, let's say a file of data, and compressing it essentially into, no, that's the wrong word, that's the wrong technical word, but choosing a representation of it, which is a short, fixed length bit string, and which can go proxy for that document. So instead of comparing the two documents byte by byte, I can just compare their hashes. Okay? It's easier to do. And the cryptographic property means that you can't easily reverse that function. So if I tell you the hash, you can't reconstruct the document. Okay? It's a one-way function. And hashing is really important to the architecture of Bitcoin, so we have to know about this. Public key cryptography, you know that's part of when you go on a secure web browser transaction. Secret keys and public keys. I create a secret key, public key pair. Keep my secret key to sign things, and I give you the public key so you can verify my signature. So I keep something secret, and this also is very relevant to Bitcoin. It's part of the problem of the usability of Bitcoin, because people are having to use public keys and private secret keys for the first time, and there's lots of mistakes happening. So I can digitally sign a document by finding its hash. This is simplification. Take a document, find its hash, encrypt it with my secret key. Only I could have done that. And when you decrypt it with my public key, you get back the hash, which you can then verify against the document. And therefore, it has all the properties that a physical signature has, only for digital data. And you can easily sort of start to imagine how you might implement a digital currency. So here's a very simple version. I'm going to have some no coins. A no coin is just some values. It's a serial number and a number of no coins. So there's a 57 no coin piece, okay, with a serial number. And I can make a transaction. If I am A, I can pay B by taking the coin, the identity of A, me, the identity of B, and signing it by me. That says I am giving that coin to B. Okay, I've signed it. I've signed a statement to that effect. But first of all, there's an ownership problem, because how do we know that that coin was mine to give? And secondly, and this is the thing that really exercises blockchain and Bitcoin, is there's a double spending problem. It's just bits, right, so I can freely copy it. So I give it to you, and then I give it to you. Okay? There's nothing stopping me doing that. And the answer is to have a ledger. of all the transactions. And in that ledger, the fact that I gave it to you is recorded. And then if I try and give it to you, we look in the ledger and we discover, but I've already given that coin to somebody. So it's not allowed. And whoever's first in the ledger, that gets to be the transaction that lasts. Okay? Anything else is rejected. It's a simple solution. I haven't said anything about distributed systems. I've only talked about data so far. Okay? And Bitcoin, essentially, let's get rid of Dell update, shall we, for a start. When you make a so in Bitcoin, everything is transactions. There are no coins as such. Everything is a transaction. A transaction has inputs, which are previous transactions that were giving coins to me. And I also specify outputs, which is where I want these coins that I possess to go to. So I have some inputs and I have some outputs, and the sum of the inputs has got to be bigger than or equal to the sum of the outputs. I can't manufacture money by doing a transaction. And here's an example where these are inputs. I've got 3 units of input. I give 2 units to B, and I pay myself 0.5 in change, and the other 0.5 is a transaction fee. So that's a typical transaction in the Bitcoin system. So you say, here are some transactions that gave money to me. I'm going to use them for the first time now. This is where I want the resulting cash to go to. And what was really novel about the Bitcoin paper that introduced blockchain to the world, even though blockchain kind of existed before that, is the idea that we're going to distribute this ledger. So obviously I could just have American Express hold the ledger, right, and we're done. But that's not what's wanted. What's wanted here is some collection of parties to be determined are going to look after this ledger. They're going to replicate a ledger between them. And when we issue transactions, we can choose any of these parties. This is a simplification, by the way. You can choose any of these parties to give your transaction to. And they're going to write your transaction into the ledger. And then it's other people's job to look in that ledger and decide before, when somebody tries to give me some money, whether it's already in the ledger to stop the double spending. Okay. And it turns out, this is where blockchain comes from, that we manufacture increments to the ledger in quanta called blocks. They're just lists of transactions which refer back through the hash of the previous block, and so it's a chain of blocks. You start with the initial block, you start with the first ever Bitcoin transaction, and you create a series of blocks. This is why it's called blockchain. Each of these blocks is a new set of transactions that refers back. And so you have a number of parties which are trying to add blocks to manage the ledger for us. And we create this chain, and these things actually compete to create the chain. This is part of the economics and the game theory of blockchain. These entities compete to add to the chain. And at any one time, there's as you like, the longest chain is the true chain, and then there are aborted attempts by others to create the chain. So as we go along, these are competing to add to the chain. Whoever gets first and makes the chain longer first wins. Okay. But what if the miners behave badly? So I've forgotten to say an important thing. These are called miners, and it'll become these entities that add to the chain are called miners. It'll become clear why in a second. If they're bad guys, if there are bad guys amongst them, then they can fake the ledger. I give one version of the ledger to you and another version of the ledger to you. And if the transactions are the other way round between those ledgers, somebody appears to have paid a coin to that person, and you convince you that I paid the coin to you. But since they're the other way around in the other ledger, I convince you I paid the coin to you. That's the most fundamental attack that one can mount against this system. It's not the only one by any means. So we have to try and do something about the potential bad guys, because obviously it's money, there's going to be bad guys, right? First of all, you incentivize them. When somebody behaves correctly, when a miner behaves correctly and adds a new block, they get some Bitcoin from it. They actually get paid for doing it, first of all. That's an incentive. Second, you make the miners, and this is why they're called miners, consume computational resources whenever they create a new block. And you do that, now this is the argument, and you can certainly argue with this argument, you do that because if the good guys own more than 50% of the total computational resources, then they will win. They will make that chain longer, faster. And the good guys, the chain will be the good guys' chain. The bad guys won't be able to keep up with the good guys. And the nature of this work is called proof of work, which in fact is a misnomer, but we won't worry too much about that. Every time you create something I haven't said before, every time you create a block, you have to do some work to turn that into a valid block. It's got the transactions in it, it's got the link to the previous block in it, but you need to do something else. You need to solve this problem. The hash of you need to choose a value and put it in this block such that the hash of that block is less than a certain number. Now, I was saying to you earlier, you cannot just reverse a hash. It's not like solving an equation. You actually have to brute force compute that. So you've got to brute force find a value that's going to make the hash of this block have a value less than a certain level called the difficulty. And it's often realised as having a hash value which has a certain number of leading zeros. So if you have 20 leading zeros in the hash, and you produce a hash value that has 20 leading zeros, then obviously that is less than a certain number. And you do it randomly. You don't choose these values. This is called a nonce. It's just a one-off value. You don't choose those values 0, 1, 2. That would actually defeat the object. You choose them at random, and you keep going until you found a value that satisfies that inequality. And that is the work. That's the computational effort that you must do if your block is going to be accepted by anybody else as valid. Because everyone can check this. It's easy to check, right? It's very hard to do, but it's dead easy to check. That's the thing about hashes. Let's look at some numbers on this system. The blockchain in Bitcoin, this is, and it's none of the things that have forked off Bitcoin. This is the classic Bitcoin. Is about 170 gigabytes. The size of one of those blocks is still, there was an attempt to make this longer recently, but the size of the blocks is a megabyte. Okay. These are all defined in Nakamoto's original paper. The block creation rate is 1 per 10 minutes, and that's normative. That means that it shall be the case that on average the system does not mine more than 10 blocks. One block in every 10 minutes. It's a normative value. When you do mine it, one of the properties I've just said about randomly guessing, one of the things about randomly guessing is that the powerfulest isn't necessarily the one that wins. I might try and mine a block on some puny computer like this and be lucky about my choice of nonce. And I've just beaten, an aggregate of 10,000 ASICs in China because of luck. Okay. So this isn't necessarily happening every per 10 minutes. It might happen much less than that. It might happen more than that. But the difficulty that I referred to earlier is adjusted as the system progresses in order to normatively produce that value. Address is the name for an anonymous payee in Bitcoin, right? It's just the digest of their public key. There are about 1 million active in the last 24 hours. I think this was from a few days ago, but it won't have changed very much. And then the reward that a miner gets from mining a block decreases by 50% about every 4 years, which means that you'll never have more than about 21 million Bitcoins. It's an intrinsically deflationary currency. You cannot mint Bitcoins to your heart's content. You can only do it according to these rules. So these are economic rules. Now let's look at the transaction rate on this system, because all those parameters have a very strong effect on the transaction rate. That was whenever I did this graph on the 6th yesterday. There happened to be an average transaction. I think it's average rather than median. I can't quite remember now, which I was going through lots of charts at the time. It was 11, but typically it's about 5 transactions per second. That is a global currency is being processed at 5 transactions per second. American Express probably does a couple of orders of magnitude more than that, at least, possibly 3 orders of magnitude more than that. This system runs really slow. This system has really high latencies as well. This is median confirmation time. So when I submit a transaction, it isn't actually confirmed until the block that contains it is 6 blocks back from the end. The reason is that there's a kind of flux of competition about who's got the longest chain. If you don't leave it long enough, you might confirm a transaction only to find that someone else actually was ahead of you. So it's a pretty random number, 6, but it's the number that's used for how many blocks behind you have to be in order to be confirmed. And this gives very high latencies. Okay. Now, there's no rules actually about a miner ever processing your transaction ever, in fact. You include a fee in your transaction in the hope that some miner's going to like your fee and put it in a block. But actually, it's not uncommon for blocks just to never appear in the other end. You try again. Transactions, rather. There's no bounds on latency in this system, absolutely none. So, here are some questions and some answers. Does blockchain scale? No. A blockchain transaction cost low, like could you buy a cup of coffee with it? No. It's like, talk about $10. The average is like $10, $20 or something like that. Does it preserve anonymity? Don't count on it. It's well known that anonymous systems can be reverse engineered to correlate patterns of transactions with containing, albeit opaque identifiers, against real-world behavior and figuring out people's identities. So I'm not saying it doesn't give anonymity, but you certainly wouldn't count on it. Has blockchain been proved correct? I think the answer to that is maybe. Is it secure? Absolutely not. There was a $64 million hack against an exchange this morning. Does blockchain eliminate trust of third parties? No. Is blockchain fit for an era of global warming? It's possibly positively shameful in relation to global warming. I'm going to come back to some of these things. I saw this tweet and I couldn't help responding to it. This is somebody who's a cryptography researcher in the States, and she's noticing how low, this is Ethereum, it's slightly faster than Bitcoin, like twice the rate or something. And she compares it to the flow of traffic on the Bay Bridge, which is probably about right. We're still in early days, very early days, she says. Well, absolutely not. We're like here after this. Merkle hash trees, which it relies on, from 79. Digital cash, 83. Distributed consensus, which is a technical problem in distributed computing. This is a very famous result from 1985, which actually says that it's impossible to solve distributed consensus in an asynchronous distributed system. Mathematically speaking, even if one of your processes can fail, you cannot guarantee that a collection of computers will reach consensus unless you have timing bounds on the behavior of those machines. Hashes as timestamps, which is more or less blockchains, from 92. A solution to consensus in what's called to use a technical language, partially synchronous view, came around in 96. Smart contracts, which I haven't really talked about, but this is what Ethereum is big on, 96. Proof of work, 97. Actually, I think proof of work was first done in 92 to stop email spammers. Napster, peer-to-peer, the idea of having a perfectly decentralized system, Napster, 99. And then after a while, you get Bitcoin, and you get Ethereum up here. So it's not early days by any measure. We've been working on consensus since 1980. The thing is, though, that there is something really, really interesting and new about blockchain, or about the Nakamoto contribution to it, because we always used to look at distributed algorithms entirely from a mathematical point of view, you specify the protocol, you run a threat attack against it about all the things that can go wrong. You do a mathematical proof that protocol cannot do bad things and will do good things. But actually, you cannot analyze this protocol from that point of view because it's a socially embedded protocol. In order to understand it, you need to understand economics, you need to understand game theory, and also, it's as a matter of interest, there's a politics attached to it too. The reason for these, of course, you need to understand it economically because we're all talking about questions about is this money or isn't it? Is it cash or isn't it? I mean, I'm sure you've all read this, right? I mean, Paul Krugman, Nobel Prize-winning economist, says, no, it's not a currency. Why are you calling it a currency? It doesn't have some of the essential qualities of currency, namely stored value. Other people will say, well, it's just different. Game theory, to understand the behaviour of the actors in this protocol, it's not sufficient actually to just have a kind of standard crypto security view, but you actually need to understand how these players are going to play to their advantage, because even within the rules of blockchain, it's quite underspecified, by the way, you will find that there are ways of gaming the system. Is algorithm correct? Maybe. Well, I actually, as of a few days ago, I would have said there wasn't a proof that this algorithm was correct. I recently discovered that there's been an update to a paper. Basically, I found a paper which essentially is like 25 pages of maths, which asserts to have proved, and this is quite a recent contribution actually, so it hasn't really been tested by the crypto community, but it is a published paper, that purely from a crypto security point of view, that it is a correct protocol. But it's still a bit of a maybe, because the system assumptions about it, first of all, they assume that the set of miners is static. That's not something you can say. I mean, a miner can come online any time and do stuff. So it fails that for a start. And second, its model of a system is they've only just updated it to what I referred to earlier as partially synchronous systems, which means you have bounds on message passing delays and things like that. But that's a very recent addition, because as of when I last looked at that paper, which is a couple of months ago, they didn't even have that. They made unrealistic system assumptions in order to prove it. So that's a maybe on whether the algorithm is correct. And I would claim you have not eliminated trusted third parties, you've just moved trust to a different place. I mean, first of all, you've got to get money. I mean, ultimately, if everything was Bitcoin, then you wouldn't have these things, right? But in the meantime, you definitely do have these things. You've got to turn dollars and pounds into, and everything else, into Bitcoin. And these are the things that are getting hacked left, right, and centre. Okay? So you are, in fact, engaging with financial organisations when you use Bitcoin, unless you stay in this world and you're a drug dealer. I don't know what you do with it later. And who are these people? What do we know about them? They're extremely wealthy, because the hardware you need to be good at mining is extremely specialised hardware. You need a lot of it. You need a hell of a lot of cash to fund it. Okay. We also know that they're quite happy not being identified. And obviously they're motivated to maximise their profit in this system. They've just spent a hell of a lot of money on hardware, right? They need to get their money back. They'll do anything to get that money back and make a profit. So we've shifted things so that instead of blindly trusting American Express, I'm using that example because it's often used in this context, you have to do some game theory and some crypto analysis as opposed to reputation in order to understand whether or not you're going to trust any of these guys. Okay? But it's not that you have eliminated trust, which I frequently see being written. It's just nonsense. And this is the thing that gets my goat, really. I think there's a hell of a lot of electricity. I mean, I think I'm actually going to click on this link and see if we get... Now, there is room for debate about this, I think, just in the interests of impartiality. But even this guy says, this guy's just totally wrong. And then he says, he basically has a factor of 2 or 3 on those figures. So it's a positively shameful state of affairs. This is the 21st century. Our children are going to have the waters rising towards them, right? Long talk. So what's to be done? I have no idea where I'm on time, by the way. But anyway.
Oh, good point.
The thing about, there are a lot of parameters in that protocol I've just described to you which make it intrinsically very slow, right? But you can't just tinker with those parameters without changing the economics of it and the security threat of it. So you can't just double the block size, not make it six blocks ahead, but make it 2 blocks ahead. You can't just easily do those things without really understanding what the hell you're doing, because there's a huge amount of money at stake. And we really don't understand. There's no way you can just say, oh, well, if we double the block size, this will happen. This is an extremely complex system. But the point is that when you reach distributed consensus, one thing we know, if you look at all the history of distributed consensus protocols from the 1980s onwards, one thing you can be sure of is those are heavily multi-round protocols. Right? You can't just wish that away. You can't just turn that into the sort of latency you're going to get trying to do a search on Google. No way. It's always going to be slow compared to anything else. I do wonder slightly about the fact that this is complete overkill, this data structure, because if you think about it, this data structure orders every single transaction that ever takes place in the world. So if you and if I buy a cup of coffee from you over here, and then someone in Honolulu buys a cup of coffee from something else, those transactions are ordered with respect to one another rigorously everywhere in the system, even if they've got nothing to do with one another. And if you look at the architecture, for example, of shared memory multiprocessors and what used to be distributed shared memory systems, there's a hell of a lot of work on relaxing the memory consistency, the replicant consistency model, so that you don't actually serially order every single thing that happens, but you're smart about doing it. Because really only transactions that have something to do with one another, that's not a trivial thing to define, but say you could, need to be ordered with respect to one another. So I do wonder whether a slightly less hammer-oriented view of blockchain might be better. Are there alternatives to proof of work? Well, people have put forward a number, actually. There's a kind of famous straw man thing, which is proof of stake, where basically you, instead of burning electricity for meaningless calculations, you simply put some money in to say my block is next. So the people who've already got lots of money get their blocks ahead of other people. And you choose people at random. And there's lots of, anyway, quite complicated protocols going on in there. But I think everyone agrees that no one has really got that into anything like a plausible state. There's something called what's it? I can't remember the phrase. There's a phrase for it, but that it's
Nothing at stake.
Nothing at stake, that's it. Nothing at stake. If you get down to the nothing at stake problem, it becomes trivially easy to just fork the blockchain, and you just end up with chaos. Proof of storage people have worked on, but these things don't even exist. They're white papers. They're all unproven. And it raises the question, is it really beyond our wits to have a currency which is somehow dependent on something of social value, like carbon capture? Would be the question I would put to all of you smart people. And then my final point is just the uncertainty of this system. We really don't understand this system. I mean, you could read about it forever. You could have 6 new PhDs on it, and we still would be scratching our heads somewhat and not really sure about how it's going to behave. Because of all these different aspects to it, the crypto, distributed systems, game theory, economic aspects to it. And it makes you wonder slightly. I mean, computer scientists have actually been fairly reticent about dealing with this. It's one of those interesting cases where the non-computer scientist world, like the web, right? It wasn't a computer scientist who designed the web. Probably never, I would argue, never would have been a computer scientist who designed the web. They'd have made it object-oriented and killed it. But the important thing is that I think there is a role, finally, for computer science to have a bit more to say about this. and for other disciplines to have something more to say about it, to try and tame some of the uncertainty about it. But in the meantime, it's an amazing experiment. It's just that the price has just gone up to $15,000, and it was, what was it, 300 at the beginning of the year or something? I don't know what it was, but I mean, the percentage increase is insane. And, well, I've got a bubble about to be burst there. I mean, it's hard to understand how it would not be burst. I mean, where is the real value in this system? People are trading. If you look at the transactions, well, of course, we don't really know what the transactions are. That's the point, isn't it? It's a public record of private, of anonymous transactions. It's kind of a weird thing. But it's pretty clear that you can't buy an awful lot with Bitcoin just in ordinary life currently. A lot of it's trading. Lots of people are trading between Ethereum and Bitcoin at the moment. A lot of gambling going on in Ethereum. There's a lot of drug dealing going on, obviously, darknet stuff. But there's not a great deal that you could point to and say was real value in this system. So it's very hard to understand how this can be maintained. I end with a crypto kitty. Thank you. Questions? Questions? I don't know who was first. Do you want to go first, John?
When you said proof of work was a misnomer, what did you mean by that?
Well, because of the probabilistic nature of what you need to do, there's a chance that I, just even running it on my phone, could get lucky and my 10th choice was right. So actually, the fact that I've been able to find the right hash doesn't mean I did lots of work. That's what I mean.
But it probably proves that as a whole, as an aggregate of the network.
Yeah, probabilistically it is, because obviously that's an incredibly unlikely state of affairs, and it's much more likely that I will have done a significant amount of work in order to solve that. So it's a probabilistic property rather than a literal property. Yeah.
So my question was actually about, you said we haven't eliminated the requirement to have trusted third parties.
Yeah.
But I would say we've reduced our exposure to them by quite a bit. So if you have fiat currency in the bank, you have got 100% of the time you have to trust that bank to not lose your money, or trust that the government's going to assist and refund it.
Sure.
Whereas you say we have to trust an exchange, but you can really minimise the amount of time you're trusting them. You get your fiat and get some Bitcoin, transfer it to your private wallet. Mm-hmm. That's a very small window.
Sure.
And I suppose you've got the miners as well.
Well, they're my chief targets.
Okay. But then if you have more people running full nodes, they may not be mining, but if you have people running full nodes, then they can reject any blocks that they mine which aren't valid.
But there are, if you look at the literature, there are quite a lot of things that miners can do that are within the rules, but aren't necessarily things that you would want them to do.
Yeah.
I mean, there's things like, you could have a takeover of the system, right?
Yeah.
Because that whole question of good guys, the good guys are the ones with more than 50%. Well, why? I mean, why do you think that bad guys, or people you think are bad guys, can't have more than 50%? It could be a government, for example, who happens to be, in your view, a bad government, but they've got more than 50%, and then all bets are off, right?
But then again, game theory comes into it, because if they act nefariously, then they're going to crash your network and lose all the value they've got in it. So
that's what you say. Have you done the game theoretic analysis to know? No. Okay, well that's my point, right? That it's not that you've eliminated trust.
Yeah.
It depends who those actors are. If you're a huge miner going cheap electricity in the wastelands of China, right, then that becomes a significant player in the mining state.
Yeah.
Right?
Yeah. At the back?
How different is Ripple's approach? Because it's got a very short transaction time. Did they do anything different to Proof?
I don't know. I don't know that system. There's something called Lightning, which I do know about. But what they do is they take the transactions off the blockchain and amortize the cost by basically they're basically another financial institution, as far as I can see, that takes stuff off the blockchain and then puts it back into the blockchain again. Amortizes the cost of transactions over many transactions between the same parties. And I mean, I would argue there's a fundamental limit to how low you can make the latency of any system that works in this way. I don't know that for a fact, but I'm very suspicious of any claims, that are much better than this. Yeah.
Just a kind of common sense question, not anything about it, but the length of these chains, is there a limit on them? I mean, do you ever
No. I mean, it's currently 170 gigs, and each block is about a megabyte, and it's growing at one block every 10 minutes. It'll just go on forever. There are sort of heuristics. Somebody mentioned the full nodes. There are other nodes in this system that cache these things. You can have checkpoints that are put into the software so you don't go all the way back through history. But there is no limit logically on how big they can grow. Yep.
So I just want to make a point about Ripple. It's a system for calculating shortest chains of trust.
Right.
And the algorithm actually predates blockchain.
Right.
So this still exists as what's called Ripple Classic. But they got into the blockchain world. I don't really understand why.
Okay. Yeah.
If the blockchain's being minted is kind of based on the computational power, what's going to happen when something like quantum computing takes off, where suddenly we have a massive spike in computational power?
Yeah. So then any player who acquires that kind of power will have greater than 50%. So I think it's called the Goldfinger attack, isn't it? It's basically for obvious reasons. If somebody gets to be that person who's got all the power or has managed to persuade lots of mining pools to get together to be that, then they are the controllers. So yeah, if you have something like quantum computing, you do massively parallel, even beyond what we can dream of at the moment, hash computations. Yeah.
One thing I don't think we really touch on too much is obviously the value that these coins have, how
Yeah.
that comes around.
Yeah, because I don't understand it, but yeah.
How much people want them and don't.
Yeah.
And there's a lot going on with the big exchanges like Wall Street and New York Stock Exchange, also picking up on being able to exchange Bitcoin. If that's just going to keep going, or at some point the value is just going to...
Well, that's what nobody knows, right? There's an awful lot of people who seem to believe they can just make it keep going, but it's, it is compared to Ponzi schemes quite a lot, and I think with some justification.
Yeah, I've heard it compared to a scheme from a while ago, where at one point people realised that there was no value, no one wanted to buy it.
Yeah.
And it just collapsed.
Yeah. And now we have so many choices of cryptocurrencies where every time I go on a web page that has anything to do with blockchain, there's an ad at the top saying, why are you bothering with Bitcoin? Use us. Yeah.
So just to follow up on that value comment, so this might be complete rubbish by the way, but I sort of had it likened before to gold. Gold as a metal used to back a lot of currencies, not particularly useful, but the fact that it's rare and it's limited, it's difficult to find, allows for the value to be provided in it.
Yeah.
Is that?
Well, I think it's at best a metaphor for what goes on, because obviously we're mining stuff that is scarce and has an ultimate limit to it.
Yeah.
But that per se, as everyone keeps saying, the value of something is a question of people's belief in it. Right? If something only has value by virtue of our belief in it having value, and us collectively having belief in its value. So I don't.
It works for gold just because it's shiny.
Yeah, gold. It's not like, well, it is rare and it has certain value to us, intrinsic value to us, but there's nothing else really about it that's special.
You said to that it actually is used in some production processes.
Gold.
Gold.
Yeah, of course. No, it has value for manufacturing and for
Exactly, so
making pretty things and stuff. But
and as that resource diminishes, then its value, understandably, if you still need those processes, increases. Whereas with Bitcoin, if you have mined all the 21 million Bitcoins, and what do you use a Bitcoin for?
Yeah.
I'm not sure the metaphor really holds between Bitcoin and gold, because you could just set up another Bitcoin variant and just go, right, let's start from zero again. There is, you could just duplicate that, whereas you can't just say, okay, we found a new stash of gold.
Sure. No, it's different in some fundamental respects. I agree. Yeah. So there's a question up there.
So say you managed to get your hands on one Bitcoin today. What are you going to do with it?
What am I going to do with it?
What would you do with one Bitcoin?
Well, I was talking to someone who actually does use these things. I was talking to someone, I discovered that somebody who sits near me is constantly trading between Bitcoin and Ethereum. I had no idea that's what she was doing. And she was telling me that she actually got into Bitcoin really early and has made a fair bit of money. She's bought holidays with it. There are brokers who will do that. You're not going to go to British Airways and get a holiday, right? But there are people who will sell that kind of thing for
So you keep trading and ride the bubble.
Well, yeah, I mean that's what she does, but it's not clear what the exit is exactly, is it? I mean, but to her it's monopoly money because you know she only put in $100 or something to begin with, and now she's got all these thousands of dollars worth of equipment in Bitcoin. Yeah.
You've got CryptoKitties on the board, which is really quite pointed in terms of transactional intensity.
Yeah.
Obviously, Ether's got more transaction capability than Bitcoin.
By a
and
factor, yeah.
And it's even fallen over in one successful app,
Exactly.
right?
Exactly. So here, so smart contracts. So these are. I mean, it's just kind of incomprehensible to me, but they're supposed. I mean, there's no reason for CryptoKitties to be on the blockchain, right? It confers no advantage to this. You could just have a website. If nobody had ever heard of blockchain, you'd have just had a website with CryptoKitties on it. You persuade people that they would be marketable things, and of course, virtual pets do have currency in some games and things like that. It's just that idea, right? No need to have this on the blockchain whatsoever. But they trade. I looked in to see if I wanted to buy one because I thought, you know, maybe they're just a couple of dollars or something. These are like thousands of dollars and $2,000 I'd have to pay to get one of these things, and they're being traded like mad. But they're running. So smart contracts are kind of interesting because not many people know actually, but the Bitcoin blockchain is itself a programmable thing. There's a programmable notion of transaction in there. I've simplified that out. But with Ethereum, again you have a blockchain, but it's all about the smart contracts really. And these are just a little bit of code that's stored in the blockchain. So it has all this immutability property because it's stored in the blockchain and runs against data and takes transactions out of the blockchain and puts transactions into the blockchain. And it's kind of interesting. And again, this is a bit of a wild west. So the point you're making is this has pretty much brought Ethereum to its knees, right? Because all the miners, they're all executing the code for CryptoKitties, and nobody else can get any transactions through. Okay. The other thing I discovered as well to this is that the language implementations in these systems are really very poor. And there was an audit recently that uncovered all kinds of problems with the language implementations for the scripting language you use to code these things in. And that's another massive potential security leak. There's also a very interesting paper by some American researchers who got their students to script for this. And all the mistakes they made and like the massive amount of financial loss there could have been because of the bugs in those programs. Right? So it's not just like debugging any old program. You're debugging a program which could, as it were, spin out of control, could give money away, could do all kinds of really bad things in terms of financial transactions. So there's a whole other story behind smart contracts as well. That's a very Wild West kind of thing at the moment. Thank you, everybody.
Yeah, great.